Introduction to Data Analytics, the new currency of the modern world. Welcome everyone. I am thrilled to be your guide as we embark on this journey into the heart of the digital revolution. If the 20th century will, the 21st century is undeniably powered by data. But data in its raw form is like crude oil. It's messy, bulky, and largely useless until it's refined. That process of refining is what we call data analytics. Today, we're going to lay the foundation for this entire course, covering everything from the basic definitions to the complex ethical landscapes we navigate as practitioners. Defining data analytics beyond the buzzwords. At its core, data analytics is the science of analyzing raw data to make conclusions about that information. It involves applying an algorithmic or mechanical process to derive insights and running through several data sets to look for meaningful correlations. Many people confuse data analysis with data analytics. Think of it this way. Analysis is looking backward, partitioning a whole into its components to understand what happened. Analytics is the broader discipline that includes analysis but moves toward action. It's the art of using data to solve problems, predict outcomes, and automate decisions. The data life cycle. To understand analytics, data collection, gathering raw signals from various sources, data cleaning, wrangling, removing noise, duplicates, and errors. Data analysis, using statistical models to find patterns. Interpretation/visualization, turning numbers into a story that humans can understand. The types of analytics. In the industry, we generally categorize analytics into 4 distinct levels of maturity. Each level adds more value, but also requires more technical complexity. Descriptive analytics. What happened? This is the most common form of analytics. It uses historical data to describe the current state. Examples: monthly revenue reports, web traffic summaries, or year-over-year sales growth. Tools: dashboards, pie charts, and bar graphs. Diagnostic analytics. Why did it happen? Once we know what happened, we need to know the cause. This involves drilling down into data to find dependencies and patterns. Example: if sales dropped in July, diagnostic analytics might reveal it was due to a supply chain delay in a specific region. Predictive analytics. What is likely to happen? Here, we move into the realm of machine learning (ML) and statistical modeling. We use historical patterns to forecast future probabilities. Example: credit scoring models that predict the likelihood of a borrower defaulting on a loan. Prescriptive analytics. What should we do about it? This is the holy grail of analytics. It doesn't just predict a future, it suggests the best course of action to reach a specific goal. Example: GPS apps like Waze. They don't just predict heavy traffic, predictive. They reroute you to the fastest path, prescriptive. The catalysts: big data and the Internet of Things, IoT. Why is data analytics so popular now? Why wasn't this a major undergraduate major 40 years ago? The answer lies in 2 massive technological shifts. Big data, the 3 V's. The term big data refers to data sets so large or complex that traditional data processing software is inadequate. We define it through the 3 V's. Volume. We are generating petabytes of data every second. Velocity. Data is generated at lightning speed. Think of Twitter feeds or stock market tickers. Variety. Data isn't just numbers in a spreadsheet anymore. It's emails, videos, sensor readings, and voice recordings. The Internet of Things, IoT. IoT is the network of physical objects, things, embedded with sensors, software, and other technologies to connect and exchange data with other devices over the internet. The connection, IoT is the source, and data analytics is the brain. Your smart fridge, your Apple Watch, and the sensors in a Tesla are all data factories, providing the raw material for analytics to work its magic. Industries, analytics in action. To truly appreciate the power of this field, we must look at how it has transformed every corner of the global economy. Finance. In the financial sector, analytics is used for fraud detection. Banks use real-time predictive models to flag a transaction as suspicious the moment you swipe your card in a foreign country. It's also the backbone of algorithmic trading, where computers execute trades in milliseconds based on data patterns. Human resources, people analytics. HR isn't just about gut feelings anymore. Companies use analytics to reduce employee attrition. By analyzing patterns in performance, PTO usage, and engagement, firms can predict which employees are likely to quit and intervene before they do. Marketing, This is perhaps the most visible use of analytics. Customer segmentation allows companies to group users based on behavior. If you've ever seen a recommended for you section on Amazon or Netflix, you are seeing collaborative filtering, a sophisticated analytics engine at work. Healthcare and medicine. In healthcare administration, analytics optimizes hospital staffing and bed availability. In clinical medicine, it's even more profound. Precision medicine uses a patient's genetic data to tailor specific treatments, moving away from a one-size-fits-all approach to drugs. Supply chain and logistics. Companies like UPS and FedEx use analytics for route optimization. By calculating the most efficient paths and even avoiding left turns to save fuel, they save millions of dollars and significantly reduce their carbon footprint. Government and nonprofits. Governments use data to improve urban planning, smart cities, and to predict crime hotspots to better allocate police resources. Nonprofits use donor analytics to identify which supporters are most likely to give to a specific cause, maximizing their limited budgets. Sports. If you've seen the movie Moneyball, you know the power of sabermetrics. Today, every professional team uses data to evaluate player value, prevent injuries through wearable sensor data, and even decide whether to go for it on a fourth down in football. Web analytics. This involves tracking user behavior on websites. By analyzing bounce rates, click-through rates center, and conversion funnels, businesses can redesign their digital storefronts to ensure users find what they need faster. Dark side, legal and ethical issues. With great power comes great responsibility. As data analysts, you will often find yourself in possession of sensitive information. Privacy and consent. The most pressing issue is data privacy. Just because we can track a user's location 24/7 doesn't mean we should. Regulations like GDPR, General Data Protection Regulation in Europe, and CCPA in California have set strict legal frameworks for how data must be handled. Algorithmic bias. Data is not objective. It reflects the biases of the world it was collected from. If you train a recruitment AI on 20 years of data from a company that only hired men, the AI will likely learn to discriminate against women. We must constantly audit our models for fairness. Data security. Data breaches can ruin lives. As an analyst, you are part of the chain of custody. Ensuring data is encrypted and anonymized is not just a technical requirement, it is a moral obligation. Conclusion. Your role in the data era. As we wrap up this introductory lecture, remember that data analytics is more than just math and coding. It is a way of seeing the world. It is about curiosity, asking the right questions, and having the discipline to let the data provide the answers, even if those answers challenge your preconceptions.